Dear students, today we shall learn about the fundamental theorem of arithmetic. What does the fundamental theorem of arithmetic say? It says that every composite number can be expressed as a product of primes, and this factorization is unique irrespective of the order in which they occur. That means, if I find out the factors of any number, they are going to be unique. Only the order can change. Suppose I find out the factors of 6, 2 into 3. I can write it as 3 into 2 also. So, I hope you understand every composite number can be expressed as product of primes and the order does not matter. In this, we will also calculate the HCF and LCM. Remember, highest common factor is the product of the smallest power of each common prime factor in the numbers. I repeat, HCF is the product of the smallest power of each common prime factor in the numbers, whereas LCM is the product of the greatest power of each prime factor involved in the numbers. Now, let us start with your exercise 1.2. What does the first question says? Express each number as the product of prime factors. 140. We can see here 140 can be written in the form of factors as 2 into 2 into 7 into 5. Here 156 can be written as 2 into 2 into 3 into 13. Likewise, 5005 can be written as 5 into 7 into 11 into 13. See that all the numbers are prime numbers. 7429 can be expressed as 17 into 19 into 23. So, we have expressed the numbers as product of the prime factors in all the 4 cases. Now, let us look into the second question. Find the LCM and HCF of the following pairs of integers and also verify, this is an important result, that LCM into HCF is equal to product of the 2 numbers. Let us do this. We will be finding LCM and HCF of 26 and 91 and we will also verify this result. So, let us look into this question, second question, which says that find LCM and HCF of 26 and 91. We are also supposed to verify the important result which says LCM into HCF is equal to product of 2 numbers. Now, to find out the LCM, let me take using prime factorization method, of course. We can find that 2 is the smallest prime number. So, we get here 2 13s are 26 and 91 as it is. Now, I think 13 is the next prime number, 13 ones are and 7s are 91. That means, I could write down LCM of 26 and 91 as 2 into 13 into 7, that is 26 into 7 . 182. In order to find out the HCF using prime factorization, 26 can be written as 2 into 13 and 91 can be expressed as 7 into 13. So, 2 into 13 and 91 is written as 7 into 13. What is common in these two? It is 13. So, HCF is 13. We have found out HCF and LCM. Now, the question demands the verification also LCM into HCF. So, what is LCM? 182 into HCF, that is 13 is equal to product of 2 numbers. What were the numbers? 26 into 91. We need to verify LHS is equal to RHS. Let us see, 182 multiplied by 13 . 2 ones are 2, 8 and 1, I get here 2366. And what is 91 into 26? Yes, I get LHS is equal to RHS. I can write down LHS is equal to RHS. It is 2366 in both the cases and hence verified. I hope you have understood, students. We have calculated the LCM and HCF and we have also verified the result. LCM into HCF is equal to product of two numbers. It is 2366 in both the cases. Therefore, LHS is equal to RHS, hence verified. Let us look into the next problem. Now, let us again find out the LCM and HCF of 510 and 92. In order to find the LCM, let me take 510 and 92. We will start with the smallest prime number 2, 2 2s are 4 and 1 carry here. So, 2 5s are 10, again we are left with one more 10. So, 2 5s are 10 and 2 4s are 8 and 2 6s are 12. Now, 255, 5 plus 5 is 10, 10 plus 2 is 12. So, 12 is divisible by 3. So, I can use 3 here, 3 8s are 24, 3 5s are 15 and 46. Let me try with 2 again, 2 2s are 4, 2 3s are 6. This with 5, 5 1s are 5 and 5 7s are. Okay. So, the LCM here is 2 into 2 and 3 into 5 into 17 into 23. What about the HCF? Let me write down the factors. It is 2 2s are 4, 5 5s are. Likewise, let us calculate for 92. What are the factors? 2 4s are 8, 2 2s are 4, 2 3s are 23 is a prime number. So, we have the factors as 2 into 3 into 5 into 17 and factors of 92 are 2 into 2 into 23. I think only 2 is common. So, HCF is 2. Let us multiply here to calculate 4 3s are 12, 12 5s are 60. So, 60 into 17 into 23 will give me the LCM. Multiplied by so, what is the LCM? LCM is 23,460. Let us verify the result which says LCM into HCF is equal to product of two numbers. So, LCM is 23,460 multiplied by 2 will be equal to 510 into 92. We need to verify LHS is equal to RHS. Let us multiply by 2, 2 6 are 12, 2 4s are 8 plus 1 9, 2 3s are 6 and 2 2s are 4. Let us see what is 510 and 92 on multiplication. Yes, I am getting LHS is equal to RHS 46,920. We see that LHS is equal to RHS and hence our important result is verified. I hope it is clear. We first find the LCM, then the HCF, and then we see that LCM into HCF should be equal to the product of our numbers. We got 46,920 in both the cases. So, our result is verified. Let us go into the next problem. Let us find out LCM and HCF of 336 and 54. 2 is the smallest prime number. Let me start with that. 2 1s are 2, 2 6 are 12, 2 8s are 16 and 2 2s are 4, 2 7s are 14. Now, if I try with 3, I think 1 plus 6 is 7, 7 plus 8 is 15. So, I can divide by 3. Divisibility rule I am making use here. 3 5s are 15 and 3 6 are 18. 3 9s are 27. So, again with 2 if I see 2 2s are 4, 2 8s are 16 and 9, 2 14 into 9, 2 7 into 9, 3 into 3. So, what are the factors here? It is 2 into 2 into 2 4 times and 3 into 3 into 3 3 times into 7. Yes. So, 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 into 27 into 7 will be our LCM. So, 16 into 27. 432 multiply by 7 again, it gives 3024. Let us calculate the HCF. Two 1s are 2, 2 6 are 12 and 2 8s are 16, 2 8s are 16 and 4, 2 42s are, 2 21s are and 3 7s are. Likewise, I have 54 here, 2 27s are, 3 9s are and 3 3s are. Let me list out the factors. It is 2 into 2 into 2 4 times and 3 into 7. And for 54, I have here 2 into 3 into 3 into 3. So, what are common factors? 1 2 is common and 1 3 is common. So, what is the HCF? It is 2 into 3, that is equal to 6. So, our HCF is 6 and LCM is 3024. Let us verify the result. What is that result? LCM into HCF is equal to product of two numbers 3024 multiplied by 6 should be equal to 336 multiplied by 54. So, 6 4s are 24, 2 carry, 6 2s are 12 plus 2, 14 and 6 3s are 18. Let us multiply 336 with 54, 6 4s are 24, 2 carry, 12 plus 2 14, 12 plus 1 13, 6 5s are 30, 18, 19, 20, 21, 2 carry and 17. So, 4, 4, 4, 8, 1. Something went wrong. 336 into 54. 6 5s are 30, 3 carry, 15, 18, 1, 6. Yes. So, 18144 is the RHS, LHS is also 18,144. Therefore, LHS is equal to RHS and hence verified. Okay, we were calculating HCF and LCM of 336 and 54. For LCM, we have taken the numbers together and we are finding the factors starting with the smallest prime number 2. 2 1s are 2, 2 6s are 12 and 1 carry, so 2 8s are 16. Likewise, 2 2s are 4 and 2 7s are 14. In this 3 5s are 15 and 3 6 are 18 and 3 9s are 27. Thus, we have taken 2 common here, taking 2 as a factor, 2 2s are 4, 2 8s are 16 and 9 is not going. So, 9 comes as it is, 2 1s are, 4s are and 9 again. So, 2 7s are 14 and 9 can be factored as 3 into 3. So, LCM is 2 power 4 into 3 to the power 3 into 7, which on calculation gives us 16 into 27 into 7, that is 3024. Now, we have calculated the LCM as 3024. For HCF, we are finding by prime factorization method 336 can be split as 2 into 2 into 2 into 2 into 3 into 7 by finding the factors, and 54 can be written as 2 into 3 into 3 into 3, and we can see that 2 and 3 are the only common factors in these two numbers. Therefore, HCF is 6. Now, we need to verify the result. LCM into HCF is equal to product of two numbers. What was the LCM? It was 3024 and what was the HCF? 6. So, 3024 into 6 gives me 18,144 and the product of two numbers 336 and 54 also gives me 18,144. Thus, verifying the result as LHS is equal to RHS. Thank you. Let us look into the next question. So, students, let us look into the next question, question number 3, which says find the LCM and HCF of the following integers by applying prime factorization method. Numbers are 12, 15 and numbers are very small and very simple. Let us see how I can write 12. 12 can be factored as 2 into 2 into 3 and 15 can be factored as 3 into 5. 21 can be written as 3 into 7. Now, HCF is 3 because only 3 is common in all the 3 numbers. And what about LCM? LCM we will be taking the higher power, that is 2 square into 3 into 5 into 7. So, we have 420 as LCM. In the next question, we have to again find LCM and HCF for 17, 23 and 29. Very interesting because can you see all the 3 numbers are prime numbers. 17 has only 2 factors 1 and 17, 23 again has only two factors 1 and 23, 29 again has only two factors 1 and 29. So, HCF obviously is 1 and LCM is 17 into 23 into 29. So, that is 11,339. In the third one, we have 8, 9 and 25 as the numbers. 8 can be written as product of 2 into 2 into 2 and 9 as 3 into 3, 25 as 5 into 5. So, the highest common factor obviously, because there is no number which is common. So, highest common factor is 1 and LCM is 2 into 2 into 2 into 3 into 3 into 5 into 5 and the product comes out as 1800. So, it was simple to calculate the LCM and HCF using prime factorization method. Let us look into the next question, question number 4. We are given that HCF of 306 and 657 is 9. We are supposed to find out the LCM and this is very popular question often asked in board exams. We are given the HCF and we are asked to find out the LCM. So, we have just now learned the rule that LCM into HCF is equal to product of two numbers. We can directly use that rule and we will have LCM into 9 is equal to 306 into 657, which can be calculated as LCM is equal to 306 into 657 divided by 9. Now, see 6 plus 3 is 9. Is 9 divisible by 3? Yes. I can cancel out with 3 and on simplification you will get here 22,338 as the LCM. Have you followed? Yes. Let us look into the next question, question number 5. This is based on logical reasoning and fundamental theorem of arithmetic. The question says, check whether 6 to the power n can end with the digit 0 for any natural number n. What is the question? Question says, check whether 6 to the power n can end with digit 0 for any natural number n. Now, if the number 6 to the power n were to end with digit 0, then it would be divisible by 5, because if it is divisible by 10, it should have factors 2 and 5, right. So, that means it should be divisible by 5. That is, the prime factorization of 6 would contain the prime 5, but just look at 6. 6 to the power n has only two factors. What are they? 2 into 3 to the power n. So, the primes in the factorization of 6 are only 2 and 3. So, the uniqueness of fundamental theorem of arithmetic guarantees that the factors of 6 to the power n are only 2 and 3 and not 2 and 5. Alright. So, there is no natural number n for which 6 to the power n ends with digit 0. I hope it is clear. Now, let us look into the next question. The question is, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Let us just recollect what are composite numbers. Numbers having more than two factors are known as composite numbers. Let us see why they are composite numbers here. Just observe that 7 into 11 into 13 plus 13 can be written as 13 into, what I am doing here? I am taking 13 as common, 13 into 7 into 11 plus 1. Now, I can solve this inside the brackets. 7 into 11 is 77 plus 1, that gives me 78. So, 13 into 78 are the two factors, which again can be factors as 13 into 13 into 6. As it has 13 and 6 as the factors, therefore, it is obviously a composite number. In the next one, I have 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Can you see 5 here? I can take common in both the terms. We have here 5 into 7 into 6 into 4 into 3 into 2 into 1 plus 1. that can be simplified as 5 into, when we multiply these numbers I get 1008 plus 1, that gives me 1009. So, the two factors are 5 and 1009, suggesting that it is a composite number, okay, because when the factors are more than 2, it is said to be a composite number. Only prime numbers have two factors, 1 and the number itself. So, 5 into 1009, as it has 5 and 1009 as its factors, it is a composite number. Now, let us look into the next question. Question says, there is a circular path around sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? This is the question. Now, notice the language of the question. He says, after how many minutes will they meet again at the starting point? That means, to find the time after which they meet again at the starting point, we need to find the LCM of 18 and 12 minutes. LCM means least common multiple. Here 18 can be factored as 2 into 3 into 3 and 12 can be factored as 2 into 2 into 3. Therefore, LCM of 18 and 12 is 2 into 2 into 3 into 3, that is 36. Therefore, so they will meet again at the starting point after 36 minutes. I hope it is clear. Now, it is the time for assignment. We have the questions for you. Write the smallest number which is divisible by both 306 and 657. Just notice the language of the problem. He says he is not asking us to find LCM or HCF. We have to use our understanding of the concept. Smallest number means least common multiple. I have to find out for 306 and 657. Next question, explain why 3 into 5 into 7 plus 7 is a composite number. Question number 3, express 429 as a product of its prime factors. Fourth question, what is the HCF of the smallest composite number and the smallest prime number? I can give you a hint here. What is the smallest composite number? 4. And what is the smallest prime number? 2. Now, I think you can find out the HCF. Next question, consider the number 4 to the power n, where n is a natural number. Check whether there is any value of n for which 4 to the power n ends with the digit 0. So, students, we have completed exercise 1.2 and here are some questions for you to try as assignment. We are having a couple of questions, 5 questions based on the questions which you have done in exercise 1.2. Please give them a try. I am very sure you will be able to solve them. Thank you.